Hi everyone, this is Jack Long, and today we're gonna do AP Calculus BC free response question from 2019. So, we're gonna do question number 6. In number 6, we have a function that has a derivative of all orders for all real number of x. A portion of the graph of x, f, is shown above, and along with line tangent to the graph f0, select the derivative of f at x equals 0 are given in the table above. Write a third-degree Taylor polynomial for f about x equals 0. So in order to do that, we are going to do, we are going to do what fx equals. So fx at 0, which is f0, equals 3. So that's the first term. We have equals 3. And then at this very point, x equals 3, and then x prime at this point equals negative 2, because when x progresses 1, y goes minus 2. So the second term is negative 2 times x, and the term afterwards is the second degree term, which is plus 3 over the factorial of 2 times x squared, because we have it from here. We get the information from here. And same for the third one, because if and that is the third degree Taylor polynomial, you're going to have negative, because it's 23 over 2, negative 23 over 2. So you're going to have negative 2, 23, 3 factorial, x to the third, plus dot, dot, dot. So this is an alternating series as far as we can tell for now. We're going to just leave it be like that. And then now we're going to move on to b. So for b, we will have a first 3 non-zero term for the Maclaurin series for e to the x. And Maclaurin series is essentially Taylor series at x equals 0. So we should be all pretty familiar with what e to the x is at this point. It is 1 plus x squared over 2x. So that's the first 3 non-zero terms. So we're done here, but we can go on and on if you want, but we're not. Okay, now we have e to the x, and it's asking for e to the x times f to the x. So now we're going to be more careful. We have to match these two together. So in the order, the way we do that is first we do the constant terms. Highlight. Yeah, the constant term is 3 and 1. So 3 times 1 is 3. And then we need the first degree term. So it's 3 times x and negative 2 times 1. And we get negative 2x plus x. Yes. Actually, negative 2x plus 3x, which is x. So 3 plus x. And then we get the second degree term. The second degree term is, we have, so 3 times this, and negative 2 times this, and then we also have the two second degree term themselves. And so the entire thing becomes negative 2x squared plus 2 factorial 3x squared plus 2 factorial 3x squared. So this entire thing becomes actually negative 2 plus 2 over 6, which is 3x squared. So it's 3 minus 2, and it becomes x squared. And that will be our third term. Plus, this is a little bit tricky, but now we're done for this question. We're going to keep on going. So for C, we have let h be the function defined by blah, 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 blah. So it's so we need to keep in mind that it's this. And we have up here the graph of f of t. So use the Taylor polynomial found in part A to find an approximation for h equals 1. So first of all, hx is, so what hx equals, it is the integration of fx. So we're going to integrate all these terms in the fx. So first of all, the first term is 3x. Yeah. And then the second term is negative x squared. The third term is 1 over 2 factorial x to the third. And the fourth term is 2 over 23, 3 factorial times 4, x to the fourth. So that, and now we plug in h equals 1 into this. So it becomes 3 minus 1 plus 2 over 1 minus 6 over 223, and the whole thing equals to 7 over 12. So the fourth one, it is known that the Maclaurin series for h converges to hx for all real numbers for x, and it is also known that the individual terms of the series for h1 alternate in signs and decrease in absolute value to 0. These are alternating series tests, error bounds, to show that the approximation found in part C differs from h1 by at most 0.45. Okay, so in order to do that, first we need to understand what alternating series error bound is. So alternating series error bound, so now we have the fx to its 1, 2, 3, 4th term. So in order to find its error bound, we need to find the next term in the alternating series, and the error will be smaller than the next term. So now we have 4 terms, and in fx we want to find the 5th term, and the 5th term will be something like plus factorial 4, and we can refer back to this chart. We have f to the 4th degree derivative is 54, so it's 54 x to the 4th minus blah 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 blah. So that's the 4th, that's the next term in fx. But then keep in mind h is actually the integration of fx, so we need to integrate this also. And in order to do that, we get 4 factorial times 5, 54 x 5th. So if we take the absolute value of it, this will be smaller, and this will be bigger than the error. So and then if we do it out and we plug in h equals 1, this thing becomes 120 over 54, which equals 0.45. Therefore, we can know that so the answer in part C differs from h equals 1 by at most 0.45, because we just prove it with alternating series error bound. And that is how you do AP Calculus BC 2019 question number 6. Thank you for watching.